Welcome to aminacademy.com. In linear algebra regarding homogeneous system of linear equations, let us do some solving problem. Find the dimension and basis for the general solution W of the homogeneous system. Look at this. This three equation is given in system. There are 5 variables but 3 unknowns. Here we have to reduce the system in echelon form. The operation is L2, that is this L2 gives minus 2 L1 plus L2. That means this equation 1, 2, 3, that second equation gives, multiply with 2 with first equation and add with second equation, which gives this x1 will go. That means 2x1 minus 2x1 gives 0, like this, which gives, and another operation L3 gives minus 5L1 plus L3 later. First look at the first equation we are writing as it is. Look at this, x1 plus 2x2 minus 3x3 plus 2x4 minus 4x5 as it is. This, look at this second equation is L2 minus 2L1, that is 2x1 minus 2x1 is 0, 4x2 minus 4x2, that is minus 2 into 2 is 4x2, gives 0. That means x1 and x2 will go. Then x3 gives, look at here, minus 5 x3 minus 2 into minus 3, that is plus 6. Therefore, which gives minus 3, here x3 comes like that. Here this operation at minus 3x4 plus 2x5. So, look at this, after this operation we have to give, that is L3 gives minus 5L1 plus L3. L3 is the 5x1 plus 10x2 minus 13x3 plus 4x4 minus 16x5. Suppose if you multiply with minus with first equation L1, which gives further, look at here, 5x1 minus 5x1 is 0, then 10x1 minus 5 into 2 minus 10, that is 0, like this. X3 gives, which gives operation 2x3 minus 6x4 plus 4x5. Look at here. Now this is the second and third equation, there is no x1 and x2. Then here this third equation is replaced by, the second equation is replaced by multiply with 2, that is minus 2 L2 plus L3 gives, suppose we are adding multiply with minus 2 L2 plus L3 gives 0 here. Therefore, that our equation, look at here, this third equation and this second equation is multiple of 2 here. If you multiply by 2 this one, which gives 2x3 minus 6 is here, minus 3 into 2 is minus 6, same for 2 into 2 is 4. So this 2 equation can be written in single equation, that is x3 minus 3x4 plus 2x5. That means both are same equation. Because it's a homogeneous, equal to 0, so this both equations is same. So we can write this as another equation. Now the system is in echelon form now. The free variables are x2, x4, x5. Here this is a pivot variable x1 and x3 is a pivot variable. Therefore, free variables are x2, x4 and x5. Hence, dimension W equal to 3. Therefore, 3 variables are there. We can say its W is 3. The solution vectors we can write for set the free variables. The basic value is x2 equal to 0, and x2 equal to 1, x4 is 0 and 0. These are basic values. By back substitution, that means that this equation we have x3 minus 3x4 plus 2x5. That equation we have to substitute the values. X3 is as it is, 3 into x4 is 0, that is free variables. 2 into 0, that is 2x4 0, so which gives x3 is 0. That back substitution, this x3 equals 0 and this set values we have to substitute in the first equation here, which is, look at here, x1 plus 2x2 minus 3x3 plus 2x4 minus 4x5. Look at here, x1 is as it is, 2 into x2 is 1, 3 minus 3 into x3 is 0, 2 into x4 is 0, minus 4 into x5 is 0, so which is equal to 0, therefore x1 is minus 2. So that vectors u equal 2, that is x1, 2, 1 and x3, x4, x5 is zeros. So now next set here, before we set x2 is 1, x4, x5 is 0, 0. Now put x2 is 0, x4 is 1 and x5 is 1. That is middle values 1 here. The same procedure we have to substitute these values in the first equation. x3 minus 3x4 plus 2x5, that is x3 minus 3 into 1 plus 2 into 0, which gives x3 equal to 3. Then x equal to 3 back substitution of this original equation, x1 plus 2x2 minus 3x3 plus 2x4 minus 4x5 0. Then you are substituting the values. x1 is here, therefore you are substituting here. Then x1 2 into 0 minus 3 into 1, 2 into x4 is 0, minus 4 into x5 is 0, so which gives x1 is 7. So our unit vector is 7, 0, 3, 1, 0. Now the same procedure, set x2 equal to 0, x4 is 0 and x5 variable is 1 here. Then the same procedure, you have to substitute this equation, this values, x3 minus 3x4 plus 2x5 equals 0, x3 minus 3 into 0 plus 2 into 1 gives x3 is minus 2. So this back substitution, that is x equals 0 in this. Then the equation, look at this one, x1 plus 2x2 minus 3x3 plus 2x4 minus 4x5. We are substituting the respective values. We are having x1 2 into 0, minus 3 into minus 2, 2 into 0, minus 4 into 1 equals 0, therefore x equals 0. That third vector is, we have to write x1, x2, x3, x4, x5, these values. Now we got the vectors u1 is this, u2 is this, u3 is this. Any solution of the system can be written as a u1 plus b u2 plus c u3, where a, b, c are parameters. Then you are substituting that u1 values, vector u1, b u2 values, c into u3 values. Now opening this, minus 2 into a, then 7 into b, minus 2c. This is the first part, that is x1. Then second, b, second value is a into 1 is a, therefore here second value is 0, third value is 0. Then third value is 0, third value is 3, that is 3b, here third value is 2, minus 2c, this is here. Then fourth value is 0 here fourth value is 1, that is 1 into b is b, and here fourth value is 0. Fifth value here 0, fifth value is here 0, here 1, therefore c is 1 is c. So we got, this is the solutions. So we are writing x1 is this, x1 is 2a minus 2a plus 7b minus 2c, x2 is a, then x3 is 3b minus 2c, x4 is b, x5 is c. So we have the solution. where a, b, c are arbitrary constant. This is the general solution under the choice of parameters. x2 is a, x4 is b, x5 is c. So here whatever the respective values a, b, c given in this set, we can get the set of different solutions. We have done. Please subscribe our YouTube channel.